For as long as scientific inquiry has delved into the origins of our universe, the prevailing explanation has been the Big Bang theory. Countless studies and the collaborative efforts of thousands of scientists have reinforced this theory, providing substantial evidence for how the universe came into being. However, the landscape of science today is markedly different from that of the past. Technological advancements continually usher in new theories and perspectives, challenging what we once considered indisputable truths. In this evolving scientific landscape, where new discoveries reshape our understanding of the cosmos, Neil deGrasse Tyson has become a prominent voice. Now, a groundbreaking development has come to light as the James Webb Space Telescope has unveiled a revelation that calls into question the long-standing Big Bang theory. This discovery involves the detection of a staggering 750 new galaxies, each of which defies our previous expectations of what galaxies should be like. Join us as we explore how the new images from the JWST debunk the Big Bang theory. With the discovery of 750 new galaxies, scientists believe in something called the Big Bang theory to explain how our huge universe came to be. According to this theory, about 14 billion years ago, the universe started existing in a big cosmic event, kind of like the ultimate birth of everything. But now, the James Webb Space Telescope has shown some pictures that make scientists scratch their heads. These images don't quite match what the Big Bang theory says should be happening in the universe. It's like the pictures are telling a different story than what scientists thought was true. The galaxies seem to be too small, too smooth, too old, and there are way more of them than expected. According to the Big Bang theory, as the universe gets bigger, things in it should also get bigger. But the galaxies in these pictures don't follow that rule. They're smaller than expected. The age of these galaxies is also weird. They look way older than they're supposed to be according to the Big Bang theory. It's like the timeline of how galaxies are supposed to form and grow is all mixed up. Another surprising thing is how smooth these galaxies look. The Big Bang theory predicts that galaxies should be kind of messy and uneven because of how they form and change. But the pictures from the telescope show galaxies that are surprisingly smooth, not as chaotic as expected. Now, let's go back to the time just after the Big Bang. Everything that makes up our universe was crammed into a tiny space. It was too crowded, and something had to change. As the universe expanded and cooled down, things started transforming. Particles like protons, neutrons, and electrons began to interact with light and energy, playing a big role in creating the stuff in the universe. In the first few minutes after the Big Bang, there was a process called nucleosynthesis. This process made simple elements like hydrogen and helium. The extreme conditions allowed protons and neutrons to come together and form these basic building blocks of atoms. Hydrogen, a really simple and common element, was created a long time ago when the universe was just starting out. Another element called helium, which is also pretty common, came about during that time too. These elements played a big role in making stars, galaxies, and other more complicated elements that came later. This coming together of basic building blocks was a huge step in how the universe changed. From being a mix of tiny particles and energy, the early universe turned into a place where matter actually started forming. This laid the groundwork for all the different types of matter and the huge structures in space that we see today. Now, the experts who study the Big Bang expected to see galaxies that were messed up and jumbled because of many crashes. But pictures from the James Webb Space Telescope tell a different story. Instead of chaotic and messy galaxies, the pictures show mostly smooth disks and well-organized spiral shapes, similar to the galaxies we see now. This surprising finding challenges the idea that crashes and mergers happen a lot in the galaxy's development, as these new galaxies don't show the signs you'd expect if you followed the Big Bang theory. If there are actually very few or no crashes happening out there, it becomes hard to believe that small galaxies can grow into much larger ones. This suggests that these galaxies were never really small in the beginning. Also, The idea that things look smaller with more distance due to expansion, as predicted by the expanding universe idea, doesn't seem to be true. As astronomers carefully studied the universe, they noticed something interesting. Galaxies like to stick together in big groups and clusters, forming a kind of cosmic network. This pattern matches what the Big Bang theory said would happen. According to the theory, the universe started really hot and dense, and as time passed, it expanded and cooled down. Gravity played a big part in shaping how matter is spread out and how galaxies form. The effects of gravity that the Big Bang theory predicted match up with what we see now. Gravity brings matter together, making galaxies group in certain places and form web-like structures that connect them. This structure shows the pattern of the universe. The presence of these galaxy groups and the connected web of matter strongly supports the Big Bang theory. Let's simplify the complex ideas in this passage. Imagine galaxies are like magical toy cars that start small and grow into SUVs by crashing into other toy cars. But the James Webb Space Telescope's findings question this idea. If the toy car analogy were true, we'd expect to see signs of collisions or dents in interacting galaxies. So, is the Big Bang theory just a play on words? Not really. There's good evidence supporting it. Firstly, the redshift of light from faraway galaxies shows the universe is expanding. Galaxies moving away in all directions support the Big Bang theory. The abundance of light elements, like hydrogen and helium, matches the theory's predictions. Large-scale galaxy distribution, observed through surveys, aligns with the Big Bang theory's predictions. A vital piece of evidence is the cosmic microwave background, CMB, discovered in 1965. The CMB, a faint radiation throughout the universe, echoes the initial moments after the Big Bang, confirming the theory. But recent research challenges this. Galaxies with ages before the Big Bang contradict the theory, suggesting it might not have happened. The James Webb Space Telescope found more galaxies than expected, challenging the theory further. The study's authors claim the telescope revealed 100,000 times more galaxies than predicted. This abundance challenges the plausibility of the Big Bang theory. Moreover, the theory is associated with 16 incorrect predictions and only one correct prediction about deuterium abundance, making its credibility questionable. The problem with the Big Bang theory goes beyond just one wrong prediction. They got the amount of helium wrong by half, and their estimate for lithium is off by a whopping factor of 20. That's a big mistake. But it doesn't stop there. The theory can't explain some things, like why things don't look smaller as they get farther away. There are also huge structures in space that shouldn't have had enough time to form since the Big Bang, and there's more. The theory has trouble explaining the density of stuff in the universe and some weird patterns in the cosmic microwave background. Even the James Webb Space Telescope, a fancy new tool, is finding stuff that doesn't match up with what the Big Bang theory says. The telescope looks at galaxies using filters that let it see in a special way. By looking at the colors of faraway galaxies, scientists can figure out how old the stars in them are. Young stars are blue, old ones are yellow or red. This helps us understand their age and lifespan. But here's the problem. According to the Big Bang theory, the farthest galaxies the telescope sees should be around 500 million years old. Yet, some of these galaxies seem to have stars that are over 1 billion years old. That's a big contradiction, because according to the theory, nothing should have existed before the Big Bang. Despite all these issues, it's weirdly not a big deal in the news. Questioning the Big Bang theory can make scientists look bad, like they don't understand the basics. It's a bit like the story of the emperor's new clothes. Everyone pretends everything is fine, even when it's not. Even a few years back, researchers who had their own money could challenge the theory, but their work often got ignored. Now, the Big Bang theory is being protected by censorship, not because it's right, but because there's no better idea to replace it. The whole situation is a bit of a mess. Cosmology research faces a tough challenge because most of its funding comes from a small number of government sources controlled by committees supporting the Big Bang Theory. This situation makes it hard for researchers who question the theory to get funds for their work, even if it's unrelated to the Big Bang Theory. This funding issue hinders progress and prevents addressing flaws in the scientific framework. It's now difficult to publish papers critical of the Big Bang Theory in astronomical journals, creating a roadblock for alternative ideas. If the Big Bang Theory isn't accurate, how did the universe form? Some theories offer different perspectives. One is eternal inflation, suggesting our universe is part of a larger multiverse with various bubble universes, each having unique physical laws. Inflation, the rapid expansion after the Big Bang, is an ongoing process, creating new universes with distinct properties. Another theory is the steady-state theory, proposing that the universe has always existed and will continue indefinitely. Unlike the Big Bang Theory, which suggests a starting point, the steady-state theory argues for a constant, unchanging universe. It introduces continuous creation, suggesting that new matter is constantly generated to maintain a consistent density as galaxies move apart. These alternative theories, however, struggle to gain acceptance due to the dominance of the Big Bang Theory in research funding and journal publications. This raises questions about the openness of the scientific community to diverse ideas and the potential hindrance to scientific progress. The idea of continuous creation suggests that the universe is always expanding, and this helps explain why it keeps getting bigger without needing a single event like the Big Bang. This process is thought to happen everywhere in space, making sure the universe stays pretty much the same over time. It's like a delicate balancing act for the universe, but there's another idea called the cyclic universe model. This model says the universe goes through a repeating cycle. It starts with a big bang, a huge explosion that begins a new universe. Then there's a big crunch, a collapse where the universe gets super dense and hot. During the expansion after the Big Bang, galaxies and stars form, and the universe becomes larger but less dense. But gravity eventually slows down and reverses the expansion, leading to the big crunch. During this crunch, everything in the universe gets squeezed into a tiny, super dense point. After that, a new cycle begins with another Big Bang, and the whole process happens again and again. Each cycle is supposed to be similar, following the same rules, leading to the emergence of galaxies, stars, and other things. So, when we spot new galaxies, maybe they're part of a fresh cycle we just happen to catch. Could this be the evidence we need to question the Big Bang Theory? If you enjoyed diving into the mysteries of the universe, hit that subscribe button and join the journey of exploring the wonders of the cosmos together.